Hello, here we are once again. And yes, we are still talking about number systems, so no, I did not erase the board. I almost did, but this is not video 8 anymore. We've left the peaceful, comfortable confines of a comfortable number system and an almost comfortable number system, and we've reached the ominous number 9. Storm clouds gather overhead. It even has a wicked sounding name, hexadecimal. Hexadecimal, like a hex, like a witch's hex. What base could that possibly be? It's base 16. Base 16 has 16 digits to work with. What foul black magic is this? There are not 16 digits available. All we have are 1, 2, 3, yada, 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 9. Whoops. Did I start with 1 when I was talking about decimal? I should have started with 0. Go back and put a 0 in there. A repair. If I broke video 7, it should have started with digit 0, not digit 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Just like we have here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Binary started with 0. 0 and 1. Okay, now, I fixed it. Here's the problem, though. We don't have 16 digits. We got to recruit new ones. We start pulling in letters of the alphabet. A, B, C, D, E, F. Why? Well, here's the rules. We got to follow the rules. You've got to be able to represent every number less than the name of the base with a single digit. Let me say that again. The rules are, in this number game we're playing called number systems, every number less than, every positive number, less than, every non-negative number, less than the name of the base, you've got to be able to represent that with a single digit all by itself. Binary, all you got 0 and 1, but that's enough because the name of the base is 2. 10, you've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Each one of those is a single digit less than the name of the base. Here's what's going on here. Base 16, I've got to be able to represent 0 through 15. All of those positive numbers with a single digit. And I run out when I get to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A all by itself represents the number 10. B all by itself is 11. C is 12. D is 13. E is 14. F is 15. Why is that all I need? Well, when I add 1 to F, I get 16. And whatever the name of the base is going to bump me over to the next column in the place value chart. So what looks like a 10 in base 2 was actually a 2. What looks like a 10 in base 16 is actually going to be a 16. I warned you. This is a mess. I'm even not going to do a very wide place value chart. Why? Because these place values get big in a hurry. This is 16 to the 0 way over here. Here's 16 to the first, 16 squared, 16 cubed. I'll do one more, 16 to the fourth. Now, all we got to do is remember every time we move over a notch to the left to multiply times 16. Yeah, if you've got a calculator handy. 16 to the 0 is 1's place. 16 to the first power is just 16. 16 squared is 256. 16 cubed is 4096. Look how big these numbers are getting in a hurry. You don't believe me? 16 to the fourth is 65536. Big, in a hurry. And this is so big over here I don't even want to talk about it. What might a base 16 number look like? Well, look at all this wonderful array of digits we have to work with. It might look like this. E, 0, F, A. These are not your mama's numbers here. This is new stuff here. We're breaking fresh ground. That is a positive number in base, number base 16. That little 16, as if we couldn't tell by looking, that little 16 says, you're not in base 10 anymore. You're not in base 2 anymore. This only makes sense thrown on a place value chart for base 16. So this particular number is going to be E, whatever the heck that was, E times place value 4096 plus 0, goodness, that'll be an easy one, thank goodness, 256 plus F times base 16. What we're doing here, remember, this expansion, this is called an expansion based on the place value chart. This is an expansion that we can multiply out and find out what the number really is. Notice I didn't do air quotes this time. What it really is, in other words, back in good old comfortable decimal number system, F times 16 plus A times 1. Now, I'm going to put an intermediate step on this. It's not even easy to do the math from here. The E, I'll look up there. E is actually 14 back in base 10, which is where we want everything to end up. So this is 14 times 4096 plus 0 times 256 plus F. F is 15. 15 times 16 plus A. A was 10. 10 times 1. Weird, isn't it? We can represent a number as big as 10, even bigger, using only one digit. Any number up through 15, we can represent in base 16 using only one digit. A miracle. Well, when we do the math, and I cheated and did the math in advance, this is actually 57,344 plus 0. I did that one in my head. I didn't need a calculator. Plus 240 plus 10 times 1. I can do that one as well. 10. Add them up, and when the smoke clears, we get 57,594. And I put the 10. We are back in base 10 now. The reason I need the 10 is, even though we went to all the trouble to convert it back to base 10, this still is a number that would make sense on the hexadecimal place value chart. It would be a huge number, but it would be 5 in the 65,000th place and so on down the line. Okay? So when we are mixing and matching number systems, as we are doing now, we will need the subscript to say what number representation we're talking about. This is back in base 10. This one was in base 16. Okay? Back to the aside. I'm doing the same aside in all of our different number systems. I'm trying to remember to do it in the same color. I can even abbreviate the question now because you've seen it several times. I'm going to just say, what? Max, meaning the largest, max in 4 hex digits. Why didn't I do 8 or 9 or 16 or something? Because I'm not a crazy person. This is going to be big enough already and just 4 blanks to fill in. 1, 2, 3, 4 in base 16. What's the max digit? F. F is the largest digit available. F, 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 F. It looks like E's. 4 E's. A jolly good fellow. No, those are all F's. That's the largest digit we have available. Oh, I don't want to multiply 15 times 4096 times plus 15 times, you know, you don't have to. That's equal to 1 followed by 4 zeros in base 16 minus 1. So now all we got to do is figure out what this number is. 1 followed by 4 zeros slapped up on our handy dandy place value chart will be back in good old base 10, 65536. 65536 base 10 minus 1, drum roll, grand finale, 65535. That's why we did those weirdo asides. It's a shortcut. It's a shorthand way to figure out what these crazy big numbers are, what the maximum number is that I can represent in the number of digits I have available. Now, that answered, I hope, every possible question you have about these number systems, decimal and binary and hexadecimal, except possibly for why. Yeah, okay. I'll get to that in the next video for the why. I'll see you online.